For decades, Toyota's reputation has been built on a single, unwavering promise: long-term reliability. From the legendary Tsuzuki V8 to the nearly indestructible 4.0-liter V6, Toyota engines earn trust not through flashy output figures, but through consistency, durability, and disciplined engineering. Introduced as part of Toyota's next-generation powertrain strategy, the 3.4-liter V6 was designed to replace the aging V8 lineup while delivering more torque, improved fuel efficiency, and lower emissions. On paper, it succeeded. In the real world, however, a growing number of owners, technicians, and engine teardown specialists began noticing troubling signs: abnormal engine noise, oil pressure irregularities, and in severe cases, catastrophic internal failures traced back to main bearing wear. By 2027, Toyota made it clear this issue would not be ignored. Through a combination of material upgrades, machining revisions, oiling system changes, and refined assembly processes, Toyota's engineers quietly but decisively corrected the engine. This was not a cosmetic update or a software patch. It was a fundamental mechanical fix aimed squarely at restoring Toyota's long-standing reliability standard. To understand why the 2027 revision matters, it's important to understand the problem itself. Main bearings are not minor components. They support the crankshaft, maintain oil film integrity under load, and absorb enormous forces generated during combustion. When main bearings fail, an engine doesn't limp, it dies, according to multiple engine builders and dealership technicians. Early versions of the 3.4-liter twin-turbo V6 exhibited premature main bearing wear under specific conditions, sustained high load, frequent towing, elevated oil temperatures, and extended oil change intervals. Ironically, these are exactly the conditions Toyota trucks and SUVs are designed to handle. An independent powertrain engineer familiar with Toyota's design philosophy summarized it clearly. This was not a single catastrophic flaw, but a tolerance stack-up problem. When tight bearing clearances, aggressive turbocharging, higher combustion pressures, and real-world operating demands combined, the margin for error shrinks dramatically. In simple terms, the engine was engineered to be powerful and efficient, but the safety buffer that once defined Toyota engines had become too narrow. One of the most confusing aspects of the 3.4-liter bearing issue was timing. Many engines ran flawlessly for tens of thousands of miles before showing any symptoms. This delayed onset made early diagnosis difficult and fueled debate over whether the problem was widespread or isolated. Master technicians point to oil film degradation over time as the primary trigger. As bearings experience repeated heat cycles and sustained load, even minor lubrication inconsistencies become magnified. Once microscopic wear begins, it accelerates rapidly. A veteran Toyota engine rebuilder put it bluntly: once the bearing surface starts to lose its protective layer, the crankshaft doesn't forgive you. From that point forward, failure is only a matter of time. This explains why some engines survived while others failed under seemingly identical conditions. Small variations in assembly oil quality, driving habits, and ambient temperatures all played a role. Toyota's famously conservative when it comes to public admissions of mechanical issues, rather than dramatic press releases. The company typically responds with incremental engineering changes, updated service bulletins, and revised part numbers. That approach is exactly what unfolded here. Industry insiders confirmed Toyota began investigating the issue as early as 2023 through warranty data, dealership feedback, and internal teardown analysis. By 2025, revised components were already undergoing limited production testing and durability validation. A former Toyota supplier engineer familiar with the process explained it simply: Toyota doesn't redesign an engine's bottom end lightly. If they touch it, they've identified a long-term durability risk they are not willing to carry forward. By 2027, those changes were no longer experimental. They became standard. The 2027 revision focuses on 4 critical areas directly tied to main bearing durability. First, Toyota revised the bearing material itself. The updated bearings use a reinforced tri-metal construction with improved fatigue resistance and greater tolerance for oil film fluctuations. This significantly increases survivability under high load and high temperature conditions. Second, the crankshaft surface finish was refined. Engineers adjusted micro-polishing processes to improve oil retention at the bearing interface, ensuring a more stable hydrodynamic oil film, especially during cold starts and heavy acceleration. Third, Toyota made subtle but crucial updates to the oil delivery system. While the oil pump design remains familiar, Internal flow routing was optimized to prioritize main bearing lubrication during high-demand scenarios. This directly addresses oil starvation patterns observed in early failures. Finally, assembly tolerances were reached. Bearing clearances were widened slightly, not enough to impact performance, but enough to restore the durability margin Toyota engines were once known for. As one powertrain durability specialist summarized it, Toyota didn't chase horsepower here. They chased consistency. The goal was predictable lubrication under all conditions. Some owners have asked why Toyota never issued a blanket recall. The answer lies in complexity. Not every 3.4-liter engine will fail, and not every early engine shows abnormal wear. From a regulatory standpoint, recalls are typically triggered by safety risks, not long-term durability concerns. Instead, Toyota opted for a rolling revision strategy, quietly improving the engine while supporting affected owners through warranty coverage and targeted service actions. While frustrating for some customers, this approach is consistent with Toyota's historical handling of powertrain refinements. As one industry analyst noted, Toyota prefers engineering solutions over legal spectacle. They would rather fix the engine for the next decade than fight headlines for a single year. For current owners of pre-2027 3.4-liter engines, the situation is nuanced. Not every engine is at risk, and many will operate normally for the life of the vehicle, especially with proper maintenance. Experts strongly recommend shorter oil change intervals, high-quality oil that meets Toyota's latest specifications, and avoiding sustained heavy loads during prolonged high-temperature operation. These practices help preserve oil film integrity and reduce bearing stress. For buyers considering a Toyota truck or SUV equipped with the 3.4-liter twin-turbo V6, the 2027 revision represents a major turning point. It marks the moment Toyota's engineering fully caught up with The significance of this revision extends far beyond a single engine. It signals that Toyota is willing to course correct even when doing so requires expensive internal changes. A retired Toyota product planner put it in perspective. Toyota's brand isn't built on perfection. It's built on learning faster than anyone else. By addressing the 3.4-liter main bearing issue, Toyota reinforces that reliability is not a marketing slogan, it's an engineering discipline. Compared to similar issues faced by competitors, Toyota's response stands out not for speed, but for depth. Some manufacturers attempt to mask bottom-end failures with software updates or revised maintenance schedules. Toyota chose mechanical solutions. As one independent engine consultant explains, software can hide symptoms, hardware fixes prevent failures. Toyota took the harder route. Early durability data from revised engines shows dramatically reduced bearing wear, stable oil pressure under load, and improved long-term consistency. Teardown specialists inspecting early 2027 engines report uniform bearing surface, minimal heat discoloration, and strong oil film retention, clear signs. The revision is working as intended. One teardown expert summed it up best. This is what the engine should have been from day one. Toyota's 2027 engine revision may not generate headlines, but it may prove to be one of the most important engineering corrections of the decade. By addressing the 3.4-liter main bearing issue at its root material, and Assembly Toyota demonstrates a commitment to durability that goes beyond marketing. For longtime Toyota owners, this revision offers reassurance. For skeptics, it's evidence that even the most disciplined automakers can stumble and recover through engineering integrity. In the end, the story of the 3.4-liter main bearing issue isn't about failure. It's about how Toyota responded, learned, and rebuilt the margin that made its engines legendary in the first place.